Good morning, Year 5. I hope you had a lovely weekend. Today is Lesson 5, and today we'll be comparing improper fractions. On Friday, we started to compare and order fractions which were less than 1. In fact, before we go any further with today's video, you may want to recap the videos from Friday just to remind yourself of your learning from that day. So when ordering fractions which are larger than 1, you will have to look at improper fractions and mixed number fractions. Today we're going to focus on improper fractions. Now the simplest of these is the fractions which have the same denominator. So an example would be 7 quarters and 5 quarters. We know that these are improper fractions because we have greater numerators than denominators. We know that they have the same denominators because in both fractions they are 4, they're quarters. So because they have the same denominator, you simply need to look at the numerator, and it's a case of which number is the largest, in which case you can see here that 7 is greater than 5. So I know that 7 quarters is a greater fraction than 5 quarters, and I need to put in a symbol to show that. Another example would be 9 fifths and 11 fifths. Once again, denominators are the same, so I look straight away at my numerator. I can see clearly that 11 is a larger number than 9, so I know that 11 fifths is greater than 9 fifths, so I need to put my symbol in here to show that. So same denominators for improper fractions are fairly straightforward. You only need to look at the numerator to work out the answer. Where it becomes slightly more complicated is where you look at fractions which have different denominators. So a problem such as 7/6 and 5/3, to work out the greater, less than or equal to fraction, the first way to solve this is to actually draw or create a fraction strip or bar. Now the key to doing these is that you must always use a ruler, and your fraction strips must always be the same length. You are interested in the fractions that is being split into. So by having fraction strips which are all different lengths, it would be impossible to compare them, so they must be of equal size. So in this case, I know I have different denominators. I've got 7/6, so these are in sixths, and these are 5/3. They're improper fractions because I have for a whole number I would have 6/6 and I have 7. My numerator is larger than my denominator, and it's the same for this problem. So first of all, if I'm going to create my fraction strips, and I've pre-drawn these for speed, I need to create 7/6. I know I have more than one whole number because there are 6/6 in one whole, and I've got 7 of them. So I create my first whole number, which would look like this as a fraction strip. 6 parts, 1, 2, 3, 4, 5, 6. I then create my next fraction strip, so I need to take a whole again, because at this time I need to subtract 7 from 6, which will leave me with 1/6. So I don't use all of this part of the fraction strip, I just use 1/6 of it. So I should now have a total of 7/6. 1, 2, 3, 4, 5, 6, 7. And remember, each fraction strip is split into 6, so I have 7/6. I do the same for 5/3. So this time my fraction strip is split into 3 parts because they are thirds. They will be the same length as the fraction strip I created for my 6, but I've split them into thirds, so I have 3 parts. Once again, I know that this is an improper fraction, and I know I have more than one whole because I have 5 in my numerator as my numerator. So I create my first whole number, which is comprised of 3/3, and then I need 2 more to make it up to 5/3, 5/3. So here you'll see I have 1 whole and 1, 2. So this will make 1, 2, 3, 4, 5/3. Visually looking at this straight away, you can see that 5/3 is the larger fraction than 7/6. So if you were going to write this, you would now write out your number sentence again. and you know that this is the larger fraction, so you will write it like this. So you know that 7/6 is smaller or less than 5/3. Another way of solving the same problem would be to use your knowledge of common denominators. So in this case, we know that we have different denominators. We have 6 and we have thirds. So we need to find a common denominator. In this case, I know that they are both multiples of 3. So I'm going to turn my thirds into sixths. So I'm going to do that because by dividing 3 into 6, I know this goes into twice using my times table knowledge. So I'm going to create an equivalent flat fraction for 5/3 in 6. So I need to times this by 2. 3 times 2 equals 6. So I have my denominator, and the numerator I times by 2 as well. 5 times 2 is 10. I'm going to rewrite out my number sentence. 7/6 and 10/6. Now, because I have the same denominator, this makes it much easier. We're simply looking at our numerators now. I know that 10 is a larger number than 7, or 7 is less than 10. So I can solve my comparison. 7/6 is less than 10/6. Here I have another example. I have 5/4 and 11/8. They are improper fractions again, because I know my numerator is larger than my denominator, and they have different denominators as well. Here we have quarters, here we have eighths. Once again, the first way you can compare these is to create your fraction strips. I have quarters here, so I know my whole is divided into 4 parts. In one whole, I have 4 quarters. So here I have an improper fraction, so I know I'm going to have one whole and then part of a fraction. So in one whole, as I said, I have 4 quarters. 1, 2, 3, 4. And then I have one additional quarter as well for my next whole. Once again, I've used a ruler. I have pre-drawn these just for speed, but they are of equal length. Then I need to recreate 11/8. My whole has been divided into 8 parts. I know this is an improper fraction, so I'm going to have more than one whole, in which case I have 8/8. So one whole is equal to 8/8, which I have here. I'll put below my quarters. But I have 3 remaining eighths from the whole, which I need to put on here as well. And if I count these up, I'll see that I have 11/8. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11/8. Once again, using the fraction strips, I can visually see that 11/8 is greater than 5/4, or 5/4 is less than 11/8. I would write out my number sentence like this: 5/4 is less than 11/8, and solve my problem. Remember, it's really important when you draw these that your fraction strips are the same length. It is really important that you use a ruler. It is really important as well that when you are separating your whole into its parts, they are equal, whether it be quarters, eighths, or thirds. It does not matter. If you don't do this and you end up with irregular sized fraction shapes, then your answer will be incorrect. My second way of solving this is to go back to my knowledge of common denominators and to find an equivalent fraction. So in this case, I have to compare 5/4 and 11/8 to find out which is the larger, smaller, or equal to fraction. In this case, I'm looking at this and I can see that my denominators are different. However, using my knowledge of times tables, I can see that they are both multiples of 4. And I can see that 4 divides into 8 2 times. So if I want to create an equivalent fraction for my quarters and turn them into eighths, I know I need to multiply this by 2. So if I rewrite this, 5/4, and I'm going to create my eighths, I will times it by 2. 4 times 2 is 8. 5 times 2 is 10. So I have 10/8. I now have the new number sense of 10/8 and 11/8. And when I compare these, I can see I have the same denominator now, so this makes it a simple situation of looking at my numerator, and I can see that my numerator in this fraction is larger than this one, so I know that 10/8 is less than 11/8. And I solve. And you can see it comes up with the same answer as we had before when I did my visual bar method. Except this time I've found an equivalent fraction of 10/8. I'd now like you to pause the video and try and solve this problem independently, please. We have to compare 3/2 and 7/6. So hopefully when you were solving this, you recognize that you had improper fractions because the numerator is larger than the denominator, and you recognize that we had different denominators. So for the first one, we have 3/2. So I know because it's an improper fraction, I have at least one whole, and I have one more half. So I have my 3/2. I then create, using my fraction strips, my 7/6. Once again, I know because in improper fraction, I will have at least one whole, and then part of a fraction, in which this case, I have one more sixth. And when I compare these visually, I can see straight away that the 3/2 is greater than 7/6. So when I write this out now, it becomes 3/2 is greater than 7/6. That was the first strategy. The second strategy involved using your knowledge of common denominators and equivalent fractions. You know you have 3/2 and you have to compare it to 7/6. You cannot simplify this down into halves, so you must turn the halves into 6. So in this case, I can see that they are both multiples of 2. I can see that 2 divides into 6 3 times. So I will now turn my 3/2 into 6 by multiplying it by 3. So 3/2 and I multiply by 3 becomes 6. And once again, do the same with my numerator. 3 times 3 becomes 9. I'm going to rewrite my number sentence. 9, 6, and 7, 6. Here I can clearly see, because I have the same denominator now, and I'm just comparing my numerators, that 9/6 is a larger fraction than 7/6, and I present my answer so. So well done if you got that right. Whether you use the visual formula like this or you use this formula, either way, if you got it right, I'm very happy. This is a very nice method for just checking your answers using the visual one. However, if you are more confident, then of course you can find the common denominator to solve the problem. For today's lesson, I have created a PowerPoint. On the PowerPoint, there is more information about how to find and compare improper fractions. And at the end of the PowerPoint, you will find questions, and you will also find the challenge questions. In addition to that, you will also find the answers at the very, very end of the PowerPoint. Best of luck today.